graph of the function by applying the leading coefficient test. Find the zeros of the polynomial, plot sufficient solution points, and draw a continuous curve through those points. So first we look and see what the leading coefficient will tell us. Our beginning behavior, our ending behavior. Is it this, 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 or this? For this one. Remember, we have this, 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 or this. What does the 4 tell us? This or this? This. What does the 1 in front of the x tell us? This or this? Okay? So it's like that. We don't want to graph that yet because we don't have any points, but we know that it should be something like this, right? Find the zeros. So set it equal to 0. Factor out x squared. And then that factors. So x is equal to, when I set each factor equal to 0, it's equal to 0 for the x squared. It's equal to negative 2 for the x plus 2, and it's equal to positive 2 for the x minus 2. So we have to refer to the factors to see what the multiplicity is. It didn't tell us to look for the multiplicity, but we need to know it whenever we're graphing this. So first let me plot the points. 0, negative 2, positive 2. So we know our graph from these points here are going to go up like that, right, from the leading coefficient test. But we need to know what's going on in between. So this is even or odd multiplicity? Even. And what is it going to do? So if it's even, will it pass through? Will it bounce or will it wiggle? Do you remember that part? Bounce. And are these two even or odd? Or both? Or they're both odd. And are they going to pass through or wiggle? What's the exponent for the 1, right? And that's a pass through. It's not a wiggle, right? How many turns will we have? Should we have? 3 turns. This is just to help us. Let's see. Is that everything that we need? Okay. So we know that this is happening, right? And since at negative 2, it's a pass-through, it's going to go down. It's not going to bounce and go back up. It's going to go through. It's going to pass through. And then when it comes back up, it's going to turn. It's going to come back up, and it's going to bounce at 0. So it's not going to go through. It'll bounce and go back down. And then it's got to turn and come back up and pass through positive 2. Well, we don't know how far down to go between here. So what we want to do, that's where part C comes in. Plot sufficient solution points. So what I would do is this. Pick a number between negative 2 and 0, and I pick the midpoint. So I'm going to use negative 1. And then between 0 and positive 2, I'll use positive 1 and see what I get for x. And that should take me to the turn. So if I plug in negative 1, I get negative 3. If I plug in negative 1 here. If I plug in 1, I get negative 3. So negative 1, negative 3, positive 1, negative 3. So I pass through at negative 2. I have to turn and come back up and bounce at 0 and pass through at positive 2. There's my graph. Yes? The multiplicity tells us that. It tells us what happened. The multiplicity tells us what happens at the zeros. So if it's if the exponent is 1, it passes through. If the exponent is even, it bounces. If the exponent is odd and not 1, it wiggles. A wiggle looks like a pass-through. So odd looks like a pass-through, but because it's not 1, it's going to wiggle a little bit through it. So, like if it's 3, 5, 7.
Yeah, bounce is 0. Oh, bounce. When it hits 0, it's going to bounce.
Yes. Not because it's 0, but because the exponent is 2. It's even. Mm-hmm. All right, let's do one more. Wherever it is. Same directions. So what are we doing here? Are we doing this, 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 or this, according to the leading term? This. That's correct. Okay. So we know that on the left side it's going down and on the right side it's going up. Let's find our zeros so we'll know where to put that start and end our graph. So we first want to factor out a 3x. And that would be x minus 2 times x minus 3. Do I need to review factoring? So x is equal to, when I set this equal to 0, what do I get? 0. When I set this equal to 0, I get 2. And when I set this equal to 0, I get 3. And do they all have the same multiplicity, or are they all different, or all the same, and they're all odd? Odd multiplicity. So if they're odd and they're 1, what will they do? What will it do with those points? Pass through. And how many terms? 2. Okay. 0, 2, and 3. So we know this is going like this and this is going like this, right? But we need to find out what happens in between. Well, we know it's going to pass through, so that means we're going to go up, turn, go back down, turn, and go back up. It didn't bounce, it passes through at all 3 points. Let's plot some points here. Let's do between 0 and 2, let's do 1, and between 2 and 3, let's do 2.5. So if I plug in 1, I get 6. When I plug 1 into this original formula, or equation, function. When I plug in 2.5, I get something I cannot do in my head. You'll want to do that in your calculator. I believe it's 1.9. Negative 1.9. So I'm going to plot those 2 points. Okay. So at all 3, I'm going to pass through. So go up, pass through, and back. So really, it's really better to not do the beginning and the ending behavior first, because look how that really shouldn't look like that. Because it didn't wiggle, it just passed through. So let's just analyze this just for a second. Look at what x cubed looks like before you do anything to it, the parent function. This is the parent function of that function. So those other numbers, what are they doing? What are those numbers doing to this graph? It's moving it, it's shifting it, and it's almost like you attach a string here and here, and you're pulling it to where instead of it just wiggling through one part, this is being stretched away from that, right? So you can see how it's similar to the parent function. Yes?
When it hit 6 on the y, it bounced.
Okay, but this behavior is only where it crosses the x-axis. What is it doing when at the zeros?
When it's, when it pops up to 0.
Yeah. Yeah, when you're testing the multiplicity, that's just what the behavior of the graph is doing when it's going through the zeros.